In this video, we're computing the definite integral of x plus pi times sine of x on the interval 0 to pi over 2. And this is definitely an integration by parts type of integral because I noticed the x plus pi part would get a lot simpler if I differentiated it. So I'm going to let u equal x plus pi. And this means that du is equal to dx. And to figure out what v is, we integrate. And we get negative cosine of x. And then we apply the integration by parts formula. So our original integral is going to turn into u times v. That's x plus pi times negative cosine x. And I'm going to move the minus sign out in front. And that's evaluated on 0 to pi over 2. Minus the integral of v du. Well, v has a minus sign in it, so I'm going to go ahead and use that to cancel the minus sign out in front of the integral. And so v is in there, and then du is just dx. And this is still a definite integral from 0 to pi over 2. In the next step, we'll go ahead and evaluate across the limits of integration in the first term. And I noticed that when I sub in the pi over 2, the cosine of pi over 2 is 0, so this one vanishes. Then I subtract the lower limit and I sub in x equals 0, which means this x in that term out in front vanishes. And then cosine of 0 is 1. So I'm left with just a negative pi, but remember that term was subtracted, so I end up with positive pi. And then I compute the second integral over here, and I get sine of x evaluated on 0 to pi over 2. And when I sub in the lower limit there, I get the sine of 0, which is 0, so that one vanishes. When I sub in the upper limit, I get the sine of pi over 2, which is 1. So we get pi plus 1, and we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.